In this video, we are going to go over exponential growth and decay word problems, or sometimes known as how things grow and depreciate, or appreciate and depreciate. Let's check it out. So in number one, it says, suppose the population of a town is 17,100, I'm assuming that's people, and is growing by 1% each year. So that growing means that we are increasing by 1% each year. Predict the population after 3 years. So what I often instruct students to do, and what you might be instructed to do, is come up with the function in general that will allow you to answer this question no matter how many years that have gone by. So we know this is going to be exponential because to find percentages of things, we would take a percent or multiply by that percentage, and it's 3 years, so we're going to multiply by a percentage 3 times. Repeated multiplication, exponential function. So this will be growth, again, because we're growing. Remember that the general form is y equals a times b to the x, where a is that initial amount that you start with, your starting amount, and b is the amount that you're growing by. In this case, that is called your growth factor. So how do we figure this out? Well, if a is our starting amount, then our function is going to be y equals the population we start with, which is 17,100. So we have 17,100. And that is times, and the growth factor, this one's an interesting one. Well, we know that we want the total population, so we're not just going to put 0.01 for 1%, because the total population is 100% of the population from the year before, in addition to that, the added 1%. So that's going to be 100%, or 1, plus 0.01. And that's going to be raised to the x, where x is the number of times we're going to be raising the 101% growing that we get. 100% plus the 1% we grow by. And so this simplifies down to y equals 17,100 times 1.01 to the x. In general, when you have a growth problem, you take 1 and you add on to it the percentage that you're growing by. 100% of where you started, all of this population, plus the 0.01 that you are adding on to that 100%. There you have it. So in general, it's always 1 plus the growth percentage. So now we're going to use this result to find the population after 3 years. Well, the number of years is the number of times that we're going to be multiplying by 101%. So all we do is plug x in as 3. So that's going to be 17,100 times 1.01 to the third. Now this I would definitely do out in the calculator. Either type it in exactly as you see it with parentheses here, or you could just do 1.01 to the third and then multiply that result by 17,100. And the result I get, which is off the camera here, is 17,618.15, about roughly that value. Well, you can't have a population of 0.15 people, so we'll round, let's say, down. So that'd be 17,618 is the population, or people. There you have it, growth. 1 plus the percentage. Nice. Okay, now let's go into decay or depreciation. And then on the flip side of the video, I'll show you one where we'll talk about what happens when we double a population. It's pretty cool. A used car costs $17,500 and depreciates in value, goes down in value by 11% per year. How much will the car be worth in 11 years? Well, again, we are repeatedly multiplying 11 times, in fact, by a depreciation, by a percentage. So we are going to use the exponential model. Y equals a times b to the x. Your starting amount, A, is still the amount we start with. Apparently I like 17,000 because I started with that in the other problem there. So 17,500 times, and the question is, what is this b value? We know we're raising it to x, the number of years we're going to be depreciating here. Well, that b value, you start out with 100% of what you have, and you're taking away 11%, which is 0.11. Now, the way I explain this is just like if you go shopping or you're shopping online and something is 10% off. You would expect to then pay 90% or 100% minus the discount of 10%. So we would expect to have 100% minus 11%, 0.11, as the amount, the total amount that remains. So we take 89%, 0.89 of this number, and that would give us our total, just like the sales price idea that I just gave you. So this would be y equals 17,500 times 0.89x, or to the x rather. So now if we want to know how much will the car be worth in 11 years, x becomes 11, and so we get y equals 17,500 times 0.89, all raised to the 11th power. And I can't do that one in my brain. You would use a calculator for this. Again, either multiply it out exactly as you see it, or do 0.89 to the 11th, and then times 17,500. Off the board, I get 4,856. So 4,856.55, and that would be dollars. There you have it. 89% of the value of the car is what you retain each year. Done 11 times, that's how much the car is worth. So the moral of the story is, folks, when you're gaining or growing, you add 100% plus the percentage you're going up by. And when you're depreciating or decaying, you have 100% and subtract the amount that it goes down by. That leaves you with the amount that you will retain, the amount that you'll have after each time that you multiply. On the flip side of this video, we'll go over another type of exponential word problem, one that involves doubling. See you there. And here we are on the flip side, as promised, with a word problem involving doubling values. Let's check it out. A population of crickets, crickets, doubles in size every 4 months. If there are currently 450 crickets, how many will there be 4 years from now? So since we are doubling the amount, that means that we're repeatedly multiplying the total starting amount by 2, and repeated multiplication is exponential. So we'll start out with the exponential model. Y is equal to a times b to the x. And so what is that a value that we start out with? Well, the starting amount is 450 crickets. So total population y is 450 times, question is, what's that b value? What am I growing by? Well, I'm repeatedly multiplying by 2 if I'm doubling, so that's my base. That b value, the growth factor, is 2 times 2 to the x. And that right there is our function. We just need to be careful now with how often we double, because it says we double every 4 months. So if there are going to be 4 years that have gone by that we're calculating, we're not doubling 4 times. If we double every 4 months, in 1 year we double, well, 4 months is 1 time. Another 4 months, that brings us to 8 months, is 2 times. Another 4 months brings us to 12 months. So it's 12 months in a year divided by 4 gives us 3 times that we're going to double in a year. So if we double 3 times per year over 4 years, we're going to double 3 times per the 4 years is a total of 12 doubles, right? 3 times a year over 4 years, 3 times 4. So what that means is the x value, the number of times we're going to double, is 12. Whoa. So the total population after 4 years is 450 times 2 to the 12th. We do that out in our calculator and we get 1,843,200 crickets. That is a lot of, well, not sleeping, because if you've ever heard a cricket, they can be loud. Can you imagine if you had that many crickets in your yard? I don't think you'd have any more grass. And if you don't have a yard and you live in an apartment, I don't know that you'd have an apartment and be covered with crickets. Be crickets everywhere. Anyway, the whole idea here is if you're doubling, tripling, quadrupling, whatever that number is, that becomes your growth factor. It's awesome stuff.